Let's see. Okay. So what I would like to do in the next hour and a half is, let's say you start doing this. So it's an easy start to do containers. Now, what if we want to get that into production, into a container cluster? There's a lot of steps, and the idea is, could you do that very fast? So not only will I show you how you can do it, but also how you can improve the process of getting there, and do that many times a day and as fast as possible. Under a minute is a bit stretching it, but let's see how far we can get. I've just shown you an empty web application where we did the first step of moving into containers, but I have a more complete example, which is this retro gaming thing, because I like video games, old video games, and the idea is, why not build a solution that looks a bit like this? So it's my imagination of these arcade machines reporting the high scores to a web API, and the web API is consumed by a web application at the top that shows the high scores in a huge list. So it's a typical scenario, I think. It's a composing front end that could use multiple web APIs through some bus or just direct HTTP calls, and all of that together, so from the web front end to the web APIs and all the dependencies, in this case a database, all of that together is the solution. And this is fairly small, but it's an example of something that could be much, much bigger. So this is what we will start using. Now, this is where we will get started. So let's run the application first, and then I'll explain a bit more about it. So we'll run it. And in the meantime, while this starts up, I'll show you parts of the application. Are you with me so far? Yeah, good, good. So two applications, the gaming web application, and then you have the services, which is just one web API. If we look inside the web API, it's almost the same as what we just saw a moment ago. It has a program, a startup, and I did the add Docker file. And the Docker file, you should now recognize this. It's still the old one from Docker Hub, but it has the multi-stage file, and it's used for compiling. If you look at the output, then the Docker tooling, let's see, container tools, will underneath the covers use this Docker file to build the images that is used to run this solution now. The same goes for the web app, so that's the web application. It's a similar Docker file, and those two together are part of the solution. Now, one thing that is, I think, really neat is I want to run this locally first. So this is my setup, but it uses a database. I'm not sure about what you did, but when I worked locally, I always had to prepare my laptop first. I installed something like SQL Server, got it running on my local machine, and I did a lot of preparations to get all the dependencies on my laptop. Well, if you start working with the Docker tooling, you should strive for this setup where you have all your tools included in the Docker containers as much as possible. So instead of installing SQL Server, I'm running SQL Server from a container here. Perhaps you already saw that we have the gaming web app, that's the front end. We have the web API, that's also running. And we have SQL Server for Linux running here. So SQL Server for Linux is running inside of a container that is being used together from this composition, Docker Compose. This is the same part, and that's the other part. So three things that you saw in the overview that are actually all running together. So I can just clone this Git repo, hit F5 in my Visual Studio, and it will start everything, including the database. Sometimes the database is a bit slow because it has a longer startup time. Containers are usually very fast, but the container for SQL Server does a bit more. And let's see if we can have a look. So I'll do the logs for this one. So you can take the entire number in case you didn't know. So you can do this, logs for that one, or you can take enough numbers so it's unique, and then you see all the output, and this is the booting of SQL Server from a container. So that should be running there. You can even connect to it using a query analyzer or other database tooling, but that's part of my composition. So if I hit F5, now it's probably there. It will do some seeding, and it will insert one high score of Pac-Man, which takes a bit of time the first time you do that, but then it should pop up in a minute and give me the complete stack from web app to web API to database. There we go. All right. So next step, how is that possible? How can you do that? Well, one of the other things that you can do is if you're here, you do add, you can do add container orchestrator support. And you get this new dialog where you can add support for container composition or container orchestrators. I've already selected Docker Compose. And Docker Compose is the local tooling that you get with the Docker desktop installation. So that's already there, but you could also choose Service Fabric, which is that's a Microsoft Service Fabric, and that's also able to run the Docker containers. And if you know you are going to run into a Kubernetes cluster, you could do Helm, and you get all these charts with some templating, and you can build a composition using Helm charts. So I've chosen Docker Compose, and what you get from Docker Compose is, oh, that's the wrong one, sorry about that. I meant to do this. Docker Compose here is a new project type, and you set it as your starter project. And what this does is it indicates to Visual Studio that this should be the starting point of your entire solution. So having a look into the Docker Compose file, this Compose file tells me how to run this composition. And what it says is I have a number of services, I have the gaming web app, and I have the leaderboard web API. And in order to run those, you need to use an image. And if you don't have the image, this is how you build it. And it refers to each of the 2 Docker files that were added, as we saw before, like this Docker file here, that's being referred to by this path. So Docker Compose is 2 things. It's a composition of your services, but it's also build instructions by just pointing to the Docker files that need to be used to build it. You can do dependencies. So in this case, it says this is dependent on the web API, which is here, and leave it at that. This is one important file, but it's not everything, because underneath the Docker Compose file, you see this Docker Compose override. And Docker Compose override adds additional information, and you get to choose yourself what you put where. What I usually do is I keep the Docker Compose file as clean as possible. This is for running and for building, but for running it's only the unique services that need to be there and need to be built. The override is additional information for each of those things that say something about, for example, how it's run, how it's hosted. So the environment indicates through environment variables that this is development, what the listen URL should be, which port is used for HTTPS communication, and also it has some settings that are read by the application to know where the other, to have some options for what needs to be configured. It also does some volume mappings. Those volume mappings are, for example, for the user secrets. Are you familiar with user secrets? Yeah? Not everybody? Okay. User secrets. We'll talk a bit about secret management later on, but if you go manage user secrets, you'll find that there's a separate file that is not part of your source code that indicates some developer settings that should not be in a code repository. So by adding them here, they still become part of your configuration, but they won't show up in your Git repo, for example. It also, this part, it talks about networking. So this is part of the front end because it's the web app, and this is part of the front end and the back end. That's the web API. And then finally, we have the third one that we saw running, that's the SQL data. This is actually the image that we had running to have a SQL server to talk to. This one doesn't need to be built because it's an image provided by Microsoft. It does need some environment variables, and it has this password for development purposes, so that's okay to show it here. And you can give it aliases inside of the network if you want to connect to it. So these three things together give the composition, and by pressing F5, this is what happens. It starts 3 containers networked together so they can all talk to each other. Okay? Well, this is your development experience, because, for example, if you go to, let's say, one of the methods inside of the leaderboard controller, let's take the get here, and we do a new refresh. If all goes well, it should hit this breakpoint here. See, there we go. So you can, even though it's running in containers, it's doing smart stuff, so it can actually reach into your source code and does the matchup of source code versus what is executing. If you start investigating, you might think, okay, how can that happen? Because that's like really strange, especially because we just determined that only this part of the Docker file is being used at the moment. So it doesn't actually do anything. All it does is say, expose 2 ports and use this base image, and that's it. So how can it work? How can it even run anything? If you want to find out, so this is more of under the covers, and you don't really need to remember. Let me try to find it. If you go to the root of your solution, then outside of the source code, you find this OBJ directory. And I believe that somewhere here, you have these generated YAML files that are also used for Docker Compose. And inside of it, let's open this with code. You will find all the things that they do during debug to hook up, for example, your source code to the Docker container. This will have your source code, but also your bin debug folder. So the container is reaching out to your file system, and it's mapping to your local file system, picking up changes, but also running your assemblies that were built from your local machine. That's why the image itself is empty, and it's not complete to push into production. You really need the release image, or the release container image for that. Okay. So far. Questions? It's a workshop, right? So you're allowed to interact. Oh, you would like to get this presentation? Well, we can actually do that because. I'll in the break, I'll push out the source code. I think it's not in it's in a private repo at the moment, but I'll push out the code there. And you could actually, it's a different workshop, but if you go to this one, this might be good enough for now because it's almost the same solution. So you go to github.com and then my account. And I hope the internet picks up quickly. And in the meantime, I'll go to the one that is running in production. Let's see. We might have a bit slow internet here. Okay, so the solution that I have is also running in production in Azure in a Kubernetes cluster, and this is it. The workflow that we need to look at now is we know now that we can work locally, that's your inner loop, and now we need to get stuff, changes that we have out into production, and what does it take to get there? So let's put something there. Let's make a little change. All right, so we go here, and in order to do that, I will use, I will first make sure we're on the master branch. And on the master branch, I'm going to pull the latest version, so I'm up to date. And I might switch to a different internet connection. Oh, there we go. So now we have all the latest sources that are also in the repository. That's Retro Gaming 2019, working from master. One of the things that we promote as a company is a good branching strategy. We think it's good practice to choose one. Anyone, what are you using for branching strategy on Git? Do you use any particular one, or do you work from master, directly on master? No, not from, no, okay, good. Different variations of Git flow, anyone else? Oh, we encounter GitHub flow as well, but there's all these variations. What you can also do is work purely from master, but with branches, so it's trunk-based development, where you guard your master, but you only create short-lived branches and immediately merge back to master. So you could have other development branches or release branches or what you think is good, but if you're constantly releasing from master and you only have one solution to care about, then in that case you might do just create a small branch from master, work on that, test it, and then push it out. So let's go here, we do a new local branch, we'll call it live demo. We'll check out the branch immediately. So we will create this live demo, switch to it, and now we can do our changes locally in isolation. Okay, let's make a little change. Let's see what we can do. All right, so what we could do here is there is this thing where there's a limit to the searching in the list. And I'll add a bit of code that I've prepared somewhere. Let me get that bug. Let's see if it's here. Yes, this is it. So it's an obvious bug, but it's okay. So a demo bug, what's the issue here? We already know that it's defaulting at 0, so it doesn't break the contract, but immediately it starts doing the minus, so it goes into the negative, and it will be quite a while in this loop before it reaches 0 again. So this will not break anything, it will just take a really long time. It's a different version from task.thread.sleep or something as a bug. But it's supposed to be hard to find because some bugs will only appear in production, and what do you do if that happens? So anyway, this is our thing. We should have found this when we debug this locally, but I'll just check if it compiles, and if it compiles, it works. So now that we've done this thing here, let's go back, say that we want to commit the changes. So we'll add that to, and we'll say new feature for limiting search, high scores, like so. We'll commit this. It's good now. We'll synchronize it to the server by pushing it out. So it's now there, ready to be accepted on the master branch. So what I'll do next is I'll go to the project there. I'll check the source code, do a pull request. Which pull requests are there? There shouldn't be any. But it says you updated live demo, create a pull request. So I'll create a pull request. And I will say, well, this is good to go. Let's create a pull request. Now, one thing. You'll already see part of the solution why this bug should not ever reach production at all to begin with. First of all, it needs approvers. What is happening when I do a pull request? For a pull request, if we check out the branches, this is the master branch, and if I look at the master branch, it has branch policies. So I'm protecting the master branch. What it says is it requires a minimum number of reviewers. So people need to look at the code. And that's a good thing because it will improve the quality, that's one. But this is also where if you have persons that are, or in a company and you need to be compliant with a lot of things, if you have security officers, compliancy managers, this is where you have the 4I principle or maybe the 8I principle, just increase the number of reviewers. And it will mean that other people need to have inspected the code, and this is showable because nothing can get to master, and master is our truth. This will guard everything. You can uncheck this one, allow users to approve their own changes. I'm not doing it now because otherwise I couldn't approve my own changes, but this is what you should not have checked, because it would mean that if it's checked, that I can do a pull request and approve my own changes, which defeats the purpose of 4 eyes. It's your eyes and somebody else's eyes. So we'll leave it at that. But you can do other checks. For example, this one is, I skipped this intentionally for linked work items because my work needs to be traceable. And now it's not traceable because I just did something, and why did I do that? So it's hard to be in control for compliancy matters if I can't prove why certain changes were made. So this is something that you would check normally. And there's another one. There's a build policy, and it says that every time a pull request is done, it will actually trigger the build pipeline. And the build pipeline is set up on top of master, and in this case, the pull request gets built to make sure that it's of a high enough quality. Now, this is what is set up in this build pipeline, and we'll look at the build pipeline in a moment. But if we go back now to the pull requests, maybe we have some results now. So it says that the build is still in progress. We'll have a look at how the build is running, and somebody needs to approve it. And in this case, I can do that myself. So I'll say approve. You see that the check mark goes up that one reviewer approved. But if you have multiple, it needs to wait till all of the approval has made it. I'll set an autocomplete to delete the live demo branch after merging, because we don't want to have them lingering around. And I do set autocomplete, so nobody has to do, explicitly say, okay, it's you can complete the pull request. If all the checks that are here, however many you have, are completed, then we push it out into the next stage. So then we can start releasing it. Let's see, because the build is running here. You see that it's now using the Docker compose file to build each of those images. So that's why it's a good thing to have a clean Docker compose, not with all the rest of it, and it will do all of those things. The other thing, and I'll show that in a minute, is that there's more, and things are being skipped, because this is just for checking, does it compile and is it okay? So we don't need to do the entire pipeline, and we're skipping things. The main message here is this is a single pipeline that is used for the master branch, but it's also used for the pull request build. So I don't create separate build pipelines. It's one pipeline so that I can always show this is how it's being done. And let's have a look at the build pipeline. So the build pipeline here, if we edit that one, we see that it uses the Git repository. At least we will see in a moment. So here you have that, retro gaming, master. So that's where we get the sources. We don't have to do a separate build anymore. It used to be there, but you don't have to. And this step is an interesting one. This is whatever tooling you can use to do security scanning. White source bold looks at your code, and it generates a report of the code that you're using, if that has known vulnerabilities. So that's for your packages, your NPM packages, NuGet packages. And it looks at compliancy from a license perspective. Because especially for bigger enterprises, one of their main concerns from a compliancy perspective is, are we using open source code that is of a viral nature? So if you have GPL licenses, which are viral, meaning that if you use the source code in your solution, all your source code, in some cases, needs to be open sourced as well, which is kind of tricky if you have intellectual property that you want to protect, and you're using this small package that says, if you use me, everything is open source as well. So those are the packages that they want to avoid, and this is where your pipeline is already scanning for that to give you an indication, are we in danger or not? Then we do the build services. Maybe you can see by the icon, that's the Docker Compose task. And what it does is it uses the Docker Compose YAML file to do all the building. It sets some values on where the images should be stored, and we'll get to that in a second. And then it pushes them out, and this needs some explanation. But creating the image is a good step because you need to know if that will work. You're protecting master, but you don't have to push the images out to the central storage, because it's just a build for a pull request. It's not the official build. So now that it is completed, the build has succeeded, we set autocomplete, so the pull request is completed. And if we go back to our pipeline now, and this one, you see that immediately a new build started running. This was for the pull request, and this is the one that is triggering because of continuous integration on the master branch. So now the pull request merge came in, and it starts building master again. But now we will do the entire pipeline. So this is where it's going. It completed the white source bold step, and this is just a product. This is free, so it's easy to start using that. But it gives you this report, and I'm not sure if it's ready now during the build, but let's see. It is. So it gives you this complete picture of how's your vulnerability. Apparently, there's a version of Bootstrap being used inside the application that we might consider changing. And further down, it shows that licenses, I'm using an MIT and an Apache 2.0 licenses, which are okay. They're not viral, so it's green. But this is where if things go red, you might consider picking different packages, because you wouldn't be compliant and you would have a license risk. Now this is all covered inside of the pipeline, and as you can see, from pull request to the master build, everything goes through this pipeline. Nothing goes outside of it. So that's a good thing. So now we're going out. It's pushing services, which is pushing images, doing other stuff, and in the meantime, our build has succeeded. Now let's go back a little bit and take a few slides. I'll skip a few things because I want to show you this. Wait up. There we go. This is the picture. What we're doing now is we started with this part, the inner loop. So we set up our machine to do local development with Docker Compose and the tooling. After you've done that, you will go into the outer loop, and that's what we just saw part of it. So we pushed things to source control, and then we trigger this continuous integration build. As part of the build, we're pushing stuff into the container registry. And the container registry is the centralized place where your container images are stored, and they are also used from the production Kubernetes cluster. Okay. It's the release pipeline that will take care of instructing the runtime environment to get new images from the container registry. Let's have a look. And we have about a few minutes for the first break. So I'll go to Azure and show you the hosting environment that I used. So who has experience with Azure? Ooh, quite a lot of you, good. So I created a resource group for my application, and it's called Retro Gaming 2019, and it has a couple of resources in it. First of all, and I should make this a little bit smaller so more fits. It has the cluster running there. This is the one, Retro Gaming Kubernetes. It's Azure Kubernetes Service, AKS. And this is where we will be running our containers from. But it also has a key vault for storing secrets. It has the registry for storing our images. And the first step that we did is we did a push, and we pushed our new containers into this registry. A registry has repositories, and now the latest is 199. The 199 is the tag of the image that the build actually created. So if we go back here, and we have a look at the builds in general, so here, you see that this one has 199, that's the build, and that build ID is used for tagging the images that were being created. So if we look at one of the steps, if we build the services, if you build it, the image tags will be the build ID, as you can see here. So that means that our image is now relatable to the build that we did. We have an image 199, and we know that it's from this build. And the good thing is that from this build that we saw there, so this is the merged one, the CI build. If we drill into this, we can actually see that this is the commit that was being done. And in that commit, you can see all the changes that were being made. So we did a change for the namespace, and we had the leaderboard controller. And if this comes up, you can see that this exactly shows what we've done before this. All right, this is, by the way, the production website, which is still functioning. We created this bug, which shouldn't be there. And we have a build process that got started. And there was a question about the builds. So let's go back here to the builds, because I believe you had a question about it. What was the question? Yes. Publish artifacts. Yes. So push services, what that one does is it pushes out to our registry. It pushes out all of the new images that we created with the Docker Compose file. That's the 199 image that we saw. What it does immediately after that is it does something that is called lock services. And it's one of the build actions that you can choose. So you can, using a Docker Compose file, you can build the service images, you can push them, and in this case we're locking them. And locking means, well, remember what the Docker Compose file, what it looked like. So we had it here. Docker Compose, this is what it looked like, and it had these images, right? Now, I pushed them out, and their identity changes, because they're in a registry, and the registry does stuff to it. It might check everything, but it also gets a unique identity. I pushed something with a certain tag, but a tag can be easily replaced, but the uniqueness of the image is unchangeable. So what lock services does is, it actually gets back the images again. So we should have a look at the build and the individual steps. So if you look here for lock services, what it does, it pulls the image. So it's pulling again from the registry. The thing we just put there, it's getting them again. And the reason being that it now has this identity for the image. See? So this is the unique SHA-256 hash of the image. What it did after that, because it was still up to date, it put that into the build output. Let me show you that. So in this copy files, this is where I pick 2 YAML files. And we will talk about these YAML files in a bit, but this is for Kubernetes. It's for deploying later on in the release pipeline. The published artifacts are actually getting all the artifacts out that were pushed here. And if I'm not mistaken, but we need to check, it also includes the Docker Compose file. But we can check on the build. So if we go back here and we take this build, we can have the summary here. Here are the artifacts are there. Cancel. Yes, I wanted to see it in a different way. Just a second. Because you can inspect them in another way, but I think we need to download it. So inside the artifacts is this Docker Compose file, the one that we used but changed. So if we open this up, and we'll do Visual Studio Code, you see that the file is still approximately what we had, but it changed the image name to have the registry name, and it added, instead of the 199, it did this @ to give it the unique identity. So this is one thing that you could use. The other thing that we put in there is this deployment. It's the YAML files for the Kubernetes cluster. We'll talk about that in a bit, but that's for enabling a release with these images. And that's what inside of our artifacts, and they are part of this build. So if we refer to the build 199, it has these images that are uniquely identifiable in the registry, and it has this compose file and a deployment manifest for Kubernetes. Because the next step will be, we want to get it out into production. And how would you do that? So let me show you this little image here. So we are at our registry now. We want to deploy it out. So for this demo, I'll do Azure Kubernetes Service. And Azure Kubernetes Service is free managed master nodes from Microsoft Azure. So you don't have to control your master nodes. And you pay for the virtual machines that are hosting your workloads. So those are the worker nodes. There's also the option of using Azure Container Instance, which is, I have an image, host me the image as an individual container. I don't need to do compositions, no complicated stuff, just host me this process somewhere. Microsoft is working on what is called virtual Couplet. Couplet is like a plugin model for worker nodes inside of Kubernetes. And what they've done is they created this virtual Couplet where it says there is a virtual worker node inside of the cluster, and it's referring to Azure Container Instance. And Azure Container Instance can scale. So if you have one container image that you want to host and you say, give me 1,000 instances of it, all watching this massive service bus with messages, and they're all taking work from the queue, you could scale that from 0 to 1,000 to do work and then scale it back again to 0. Imagine if you could do that as the worker nodes inside of your cluster. So your cluster would go from just a few default worker nodes, and then all of a sudden 1,000 more, use it and scale it all the way back again. It's much faster and cheaper than having individual virtual machines inside of your cluster. So it's a nice combination of serverless and container hosting. Other options are Service Fabric that we saw, and you have App Service, which is for hosting web applications. And if your container image is about hosting something that will do HTTP traffic, you can also choose App Service for hosting. But this is what we need to do. We need to get a container image into our cluster. And the cluster, it has an orchestrator, which we can use through the management nodes. And we can just instruct it, do something for me, get those new images and start hosting those. How do we do that? Shall we give it a spin? So what we will do is we'll use a release pipeline. So this is the Kubernetes release. And it's a very simple pipeline. And for now, and I know that there's a question on this, we only have one environment. But you can have more environments. I'll talk about that in a bit. But this is our build, the one that we created. And it has, it's 199 now, but it says just use the latest version that is out there and start doing your work on that. First, go to, in this case, we immediately go into production. And in production, we do this kube control apply, which is telling the cluster, apply this manifest. And the manifest is a file that we handcraft inside of our solution. It's this file here. It's a deployment file. This is something like a Docker Compose file. You can host a Docker composition using Docker Compose or Docker Swarm. If you run inside of Kubernetes, it has its own format. It's a different type of file. It uses these different blocks specifying this is a service. So something is running there. This is a deployment, and the deployment contains images, container images. That is gaming web app, and you can see here that I have this placeholder for the build ID, because in the deployment manifest I need to say 199. So that needs to be inserted here. So I use another task to have these tokens. These are the markers for the beginning and the end. I mark certain things like the container registry. It could change, right? I know that from my release pipeline, because I might go into the test container registry or the production container registry if I wanted to make that distinction. There's other things that need to be in there. For example, look here. If I'm doing application insights, I need an instrumentation key. That needs to be inserted as a value for environment variables as well. But I don't want them hard-coded here, especially not this one. This one is like really scary to have here. So we keep them out of our manifest, but they need to be provided during a release. And the way that that is done is we have a task replace tokens. In replace tokens, you will see that the beginning and the end are those __ markers. And what it does, it takes all these variables and it from the release and uses that to substitute the values. So you can see that we have our container registry listed here that will be inserted into the manifest. We have a namespace where it will be hosted inside of the cluster. All is being substituted, and the client secret is here. There's other ways of doing it, but if you put it here, you can just lock it here with this lock, and then it's changed to be unreadable, and the log information will also not show it. So if you cannot get rid of the final secrets, and you have some secrets like connection strings with passwords, or in this case a client secret for the key vault, you can do it here just once by a trusted person, and that will lock it. But there are even better ways of doing it. Anyway, this is how you would substitute all of the values, also the DNS name for the hosting, all gets put in there, and then finally the other task says the file that was just changed, this YAML file, use it to do a apply. If you would do this from the command line, you would do something like kube control, apply, -f, and then go to, I believe it's deployment. And he would do this, and this would do the same, except now it wouldn't work because it doesn't have all the values substituted. But that's actually what it does. In this case, I have a, so if you do kube control, config, get contacts, we should, if all goes well, we should see that we have a context that's going to our Kubernetes cluster. So if I give those commands, I reach out into Azure, I could do it from my machine. All right. One thing, because if you start working with this and you didn't before, do you notice that these are the clusters, the Kubernetes cluster that are listed. But there's also one Docker for desktop. If you have the latest tooling, the latest Docker tooling, that is shows here, it's now called Docker Desktop instead of Docker for Windows, Docker on Windows, Docker Toolbox, the previous names. Docker Desktop gives you a way to set the context that we just saw. So if we do this and we have Kubernetes, you actually see that it pops up with a menu to pick the context that is also there from the command line. So it says now that I'm using this one, but if I switch to Docker for desktop, I actually have, as part of the Docker tooling, a single node Kubernetes cluster running on your machine. You will have it as well if you install the Docker desktop tooling. So if you want to try out what it's like to communicate with a cluster, then do the Docker desktop, and you don't need anything inside of Azure. All right, so that's what it does. And now let's see if we start a release from here. I believe we should have a look. Releases. Because remember that we triggered a build with continuous integration that created the 199 build, which created an image inside of the registry. What I also did was let me show you this. Is whenever a build is created, I have a trigger, a continuous deployment trigger that automatically triggers to production. So when the build is finished, it triggers a release. Now, since we only have one environment, that's kind of scary, right? Because we say like, oh, it goes straight into production. Well, no, there's a couple of things. We need more things, right? We have full confidence that the build guards the quality of what goes from master to a build. So it should be high quality. Still, you might be, this might be a little bit too much to go into production straight away. But there are some guards here to protect things more. So first of all, it needs to be approved at this point. You could do it straight through, but now somebody needs to click a button and say, okay, it's good that this goes to production. You can even do gates. So if you enable this, then you can add gates. For example, you can say, I want to invoke an Azure function to do something, and it should test something. Maybe we would call a REST API, or maybe we do the security and compliance assessment to make sure everything is really okay. And if that's not done, then it will automatically be discarded, so not approved, because it's not following the pre-deployment approvals. And this can be fully automated. You can even look at Azure Monitor, if you can do it before or after, to see if by releasing this, all of a sudden the CPU usage goes up. No errors maybe, but still our solution is not as good as it used to be. That can also be reason to not have approval. Well, for now, let's turn it off. So we do have the pre-deployment approvals. And we have a number of approvers, myself and a colleague of mine. And let's see if we don't need to create a release because it's already has been created here. All we need to do is drill into this and say, for this release, it's being approved. So this is the approve button, and by doing this, I'm actually saying should be good. And I didn't do a good job as an approver because this was actually bad quality. What happens now is that it starts the agent phase, so we will do the replacement of the tokens and then the kube control apply. Oh, okay, let me tell you what is happening here. So it's now waiting for an available agent and it doesn't get an available agent. Why is that? In this case, I've in order to speed up things, I've chosen not to use an agent from the hosted Microsoft pool, so the ones that are free with your Azure DevOps subscription. I'm pointing to my own machine, but it's not running yet. So let's see if we can make that work. You need a bit of, let's see. VSTS agents there. I think we need this. So what I'll do, and this sometimes goes wrong, it can't unpack, but what I do is I start a container that will install a local build and release agent. So I can run that from my own machine. And this takes just a few seconds usually, where it's downloading it, and it might be slow now, but it installs it. And if that goes well, it will start connecting to Azure DevOps, and all of a sudden Azure DevOps can push work, builds, and release to my machine. If this doesn't work, we'll go back to using the hosted one, and we'll use that one, but it was still at the local hosted pool. So this is actually the local VSTS agent. That's what it's using now, and it's called like this, local container hosted. Now let's see if this doesn't take too long. All right, in the meantime, no, they go one by one. So I thought of doing a new one. We could still do that. Let's see. What about we go back? And I'll manually trigger one, which is also still an option. So I'll do create release. But then instead of, and let me see where that is. Let's see. This is where you pick your things, and you should use, for example, this one to do the cube control apply. So if we save this one, we could create a release, and then we go to production, and let's create that as well. So release 10 has been created. Let's see what's happening here. Nothing much yet. So this might take a while. Maybe we should cancel that one because it might take too long. Cancel the deployment. So it's canceling. I think this is 9, so let's see. We need to go here now, approve this one, say approve. So even if I do a manual one, it still needs the pre-approval. Okay. Okay, let's let this run. We'll go back to that in a second. And I'll show you what will be happening there. So we need to have this working to see any changes, but in the meantime we'll go and our application is still working now, right? Because we didn't push the bad code out. If we go back to our resource group, we have this application insights. So what I did in the web application and in the web API, I added some instrumentation. And as a result of that, we gathered a lot of metrics from all the things that we said, use this instrumentation key that goes all to the same source. And here we can see what is happening. So we have some server response times. There are no failed requests just yet. Because if there would be, then they would show up here. So at the moment, it's pretty okay-ish. Apparently there were a few hiccups here, and this is where you can see where things go bad. If this spikes to a lot of failures, there's even an alert that is that you could set that indicates by mail or some other means there's something going on, you should have a look. If you want to see what is happening live, then this gets really complicated for a bigger application, but you can actually see what is happening, and you can view all the details of what is calling what and how well it's doing with response times. And if there are errors occurring, they will show up here as in very slow response times. You can do that with a live metric stream, and at the moment it's quite boring because nothing much happened. It will connect, and it has 4 servers online, and the servers online are listed below. It's actually the web API from my solution, one from the cluster that is now running, and one from my local machine, because I also ran it there, and it's all connecting to the same thing. But you can see that there's information coming in here, but there's nothing much, and you get all the trace information as well. This is what you need if you want to be really on top of your production. If you don't have this, you don't know what is going on in your cluster. So you all of a sudden you get calls from customer, why is the website down? You should have known that before the customer called, because things can happen and there might be unexpected production issues, but this should tell you if you're doing fine or not. So, for example, let's see if it's, because I'm refreshing it a couple of times. And actually, because it's now so slow, it might actually mean that our release just went live. Or maybe not. Let's see. See? It took a while, but we have now downloaded the VSTS agent. It's connected to the server, and it's listening for jobs. We were here, so let's go back to release number 9, because I think it might still be running. Oh, see. It already happened. I can see now that this is green. So the deployment to production from the 10th release, we canceled the 9 one. The 10 one is running, and this one actually succeeded. So succeeded in the agent phase. It did kube control apply, and everything is fine. Now we could have a look inside of our cluster. Let's go back there, because it's you need this single instruction here and a new command prompt. So what I'm using here is AZ. It's the Azure CLI, the command line interface. You can do something like this, list all of your clusters that you have. It's for your current account, your subscription that you have connected, and in this case it's connected to the one I showed you earlier. It's this retro gaming Kubernetes. So what I can do now is I can say browse me that Kubernetes cluster, and what it will do is it will set it as the current context, which it already was. We saw that that star, and it does a tunnel from my machine. So if I go to this URL on port 8001, it will actually tunnel me to Azure. And all the instructions that I type here go there. And if I ask for this in a browser, this is being served from the Kubernetes cluster in Azure. So if we go to our namespace, we used .NET Framework Days, and we see everything is looking pretty good, right? Because it's running, there's no red, so everything is according to plan, but still it might not be doing that well. So let's see, it's not even showing the high scores anymore. And if we go here to the live metrics, all of a sudden there's these exceptions popping up because there's a dependency wrong. Well, let's investigate. So we go to this dependency. Let's go back now, just a second. So we go back to the insights, to the application map. That's another place of watching it. And right here we should see that there's now, you see, there's some failures popping up. What is going on here? So we're doing an analyze, and we see that there's canceled requests. Okay, why? Investigating. So this is a number of them that's actually going up to 6. We should take a look because it's about dependencies. And if we take one, response was canceled, it shows me the end-to-end details. And what happened in the, this is the web application, the top one. That's the URL we visited. And it called into the web API. That's the front end calling the web API. And apparently it got an exception, and the exception it got was about, if you see the line there, the first line and the second, it says poly timeout. I created the call to from the front end to the web API with some cloud resiliency patterns using the Poly framework. And Poly applies a policy that says you should only wait 1.5 seconds. If it takes longer, just cancel the request, because then probably it's either too slow or there's something wrong. The front end shouldn't suffer because one of the dependencies goes bad. Do you understand? So this is actually happening now because we had the bug that took so long. It's more than 1.5 seconds. So the front end says it's taking too long, I'm canceling it, but it's actually quite okay because it just doesn't show it anymore. But it doesn't show this error screen saying, oh, something went really bad. No, we knew that it could happen, and it's degraded in the experience, but it's still there. The rest might still work of the web application. So we now know that something is wrong, and we can investigate a bit further if we go, because we want to know, okay, what is running inside of our cluster? And there's a couple of places where you can see, and we can have a look if this works, because this is a new part, which is sort of interesting. Go to your Kubernetes cluster in Azure portal, this one, and go to Insights. And here you can see that there's 3 nodes running, and they're all good, so good to go. It's not using that much CPU at the moment. We can see the controllers that are there. And let me see if I can, no. If we go to this one, the gaming web app, it's actually all still running, and you can see which containers are running there as well. So if we have the gaming web app, we can actually see that right here, it's image tag 199 is running there, right? So we see that our cluster is running the gaming web app. That's the one part, and this is the leaderboard, and the leaderboard is running 197. It might be an older image that is separate from it. This is actually quite strange. So there should be one more with 199. Let me check. There's another one. 197. Is there more? Yeah, this is the one. So apparently there's multiple instances running, and this is the one that is running our new latest thing, 199. We could have seen it in another way as well, because if we go back to the overview here, right here, you can also see which deployments are there. And sometimes this crashes, and I think it did. So let's go here, because sometimes this, and it will go all red on us. Let's see if we can cancel this. And start it again. There we go, switch to the right namespace. There, and then we should be able to see some deployments. And inside of the deployments, we see our composition. It's only the 2 that we need, not the SQL Server, because you shouldn't be running SQL Server from your production cluster inside of the cluster. You should use Azure Kubernetes Service. Azure SQL or some other way of hosting it. That might be good to go in that for the last 15 minutes. I'll show you a couple more things, and then we should be good to go. Because there was a question in the break, how do you deal with multiple environments? And I'll show you with a couple of pictures to just illustrate what is happening there. Let's go back a bit there. So this is what we have now, right? We have a container cluster, front end and the web API, and it connects to Azure SQL database. This is what we have now. Normally you would have a service bus, maybe a backend service that does some processing, right? We talked about this in the break as well, but also other dependencies like Redis cache or webhooks. Just think of what else could be there, but some things will be running your cluster and the rest are external dependencies. This is good for the real stuff, like production. But on your machine, or maybe in a test environment, it shouldn't have all the expensive stuff or the real things. You want to have different things. So now think about this, because this is like a big thing. If you switch to container technology, we created one image. And the image now goes through various stages that you might have. Who still uses this DTAP for releasing their software? 2, 3, 4, okay. Maybe you don't need as much anymore, but this is what traditionally was being done, because production was production and it was being managed by the operations or the run part of the company. And it's handed over to the guys from IT operations, and they guard this because this is production and this needs to be stable. So they usually go and say, we don't want changes here because it might disrupt, and we have key performance indicators. So we get a bonus or no bonus if there are too many production issues. So you need to go to acceptance, and we do a lot of rigorous testing before we allow you to change anything in production. But now we have this process that allows us to fully automatically release every time to production, and we are running production. It's not a different part of the company anymore. So as a DevOps team, that's what I'm talking about, we build it and we run it. So this is our responsibility, and if we want to change it, that's okay. So if we have confidence, why not just go to production? And it's a bold step, but we have a lot of controls in place now with the pipelines, so we should actually be very confident to get there. And we might need less of those environments. But the tricky part is your container image, if it contains settings, so typically, do you recognize this? App settings JSON, you would put your connection strings in there, and you have an app settings development JSON, app settings production JSON. But those settings, they go into the container image. And container images, they cannot be changed anymore. So once you make them, they will never change. So you can't change the connection string if it ever happens to change, because the password changes and it's in there. Or if you don't know ahead of time on what environment you need to run. So putting stuff in app settings JSON, which is okay for non-container scenarios, is actually not very useful if you do container images. So you need to be aware of your environment. Am I running in production? Am I running in development or acceptance? And take into account that the environment might change. And you should read part of your configuration, not just from the file, but also from environment variables. You would do it normally with Docker run, and then you specify your environment variables with key value pairs. But as you saw, we don't run Docker run anymore. We just do a composition, either with Docker compose, or we do it with the Kubernetes YAML file. And then we just tell the container cluster, this is the deployment file, and these are your settings. Remember this? Let me quickly show you that we had these environment variables. This is where we say it's production or not. Where we say what the connection string is, for example. So getting that in place is reading the environment variables is like an additional thing that you need to do to be able to switch between environments and keep one single image that is environment aware. And in your code, you need to cater for that. And if in your startup, what you typically see is this. So in the startup, you build your configuration, you add JSON files for app settings JSON, you add all of the ones that are environment specific. So for example, this one here, app settings development JSON. That is what this part does. And then it says, well, a couple of things. If we're running in development, we want to use those user secrets. As the last one, so the one with the highest priority is read the environment variables. And this is where the magic happens, because this will actually use this as a basis, which can contain, well, for example, it can contain your local connection strings to your local thing. Remember the password that we had? This is just the one that I'm running from my container, and this is fine. But if I'm going to test or staging or production, I will read it from the environment variables, and the environment variables are specified here. So here will actually be, there will be the real connection string. Okay. So that's this part. Yes. With that, you can actually do a lot of smart switching, because it would be really cool if we could run everything that we had on our local container cluster as well, using substitutes, so we can run as much as possible from the cluster. So you see that for local development, I have the database running in a container again, which is totally fine. Instead of Azure Service Bus, we're using RabbitMQ, a Redis cache, which can all be run from a container. So you can do that on your local development machine. You might need some patterns there for dependency injection to switch out the service bus one with the RabbitMQ provider. You shouldn't do this in production, but I already covered that. And external things like the webhooks, they need some special countermeasure because you can't put them in a container. They're not the GitHub webhook or the Slack webhook is out of your control, but you can create some stubs. So you replace your thing with the stub, and it's just like unit testing in your staging or test environment. All right. See, this is where we lost the connection again, which is okay. So let's see what we covered. So we pushed out a bad piece of code. We did the build, which was okay. Then we did the release, and we pushed it there. We were able to see with the application insight that something was wrong. And now we can backtrace because we still have our traceability. We didn't put in work items, but if you would do work items, you would get something like this. That you have work items. Let me see the board. And if I kept my remain disciplined, then I would have done something like this. So I would have had the high score limit list feature. It would have related work. I hope it pops up. Apparently not. Maybe on this one. See, this is the work that was being done. So this is the actual task with all of the changes that were made. And I can trace back each of the individual commits, the pull requests, to where the work originated, who worked on it. In this case, it was me. And that gives you full end-to-end traceability of what is running in production and what is not running there. One other thing that, or a couple of other things that to quickly go through some implementation details is if I run something in production, that's scary, right? Because we were able to just push out something and it immediately was effective. It would have been better if we did something like this. And let me check if I can quickly get that in. So this is the new piece of code, right? So I could say here, if, and now I need to remember which one it was, the leaderboard list limit feature dot is, let me see here. I think it still needs to be inserted. The limits list feature. We do an initialize of the feature. We go down, and here we will say feature dot is enabled, feature enabled. Then I will do this part of the code. There we go. Now what this does is, this is what is called feature toggles. And the idea is that somewhere else I control whether this piece of code will actually get executed. So I can switch it on or off. And initially I will have it off. I use a bit of logic in the startup. So in the startup I can do something like to configure the features. And it says, here's the limit list feature. And it uses the toggle value provider, and that boils down to here it's saying it's not enabled just yet. So what this means is that I can create new functionality, push it into production, it's there, it's deployed, but it's not released because we didn't turn it on. And if I now, and this is a static file as we know, so this is not the way to go, but if you put it inside of a different service, the value of the switch, or in a database, you could put it there, and if everything looks good, you flip the switch, and then we start using it. And we watch the errors, we watch CPU usage, memory usage, and if nothing bad happens, we're like, this looks kind of okay, and we keep it there. And then after a while, if we have confidence that everything is okay, we can actually remove the if statement. Because we know that if we keep it on, it will work anyway. So this allows you to do a release to production, or sorry, a deployment to production without releasing. You can turn it on. If it goes all wrong, you just turn it off again. and you will never have to go back to an old version of your software again. You only roll forward, you never roll back. So this is all very modern, but it allows you to get this automated pipelines for build and release, to have a very predictable, high-quality build process, a release process that does a deployment, and the feature toggling to turn on new functionality in production and turn it off again. And if you gain confidence there, you can release much faster to production. But still, if you're like, okay, we're not there yet, another way of doing it is, I believe it's this one, is releasing individual services. So it's not this one, excuse me. Then it might be this one, let me see. Also not. There should be a scenario. So they didn't do anything, it's just, this is how you can do multiple environments. So you can say, I have a test environment, I have a production environment, and there's a link between, and first I push out things into test, and then afterwards, if it's okay and approved, I go to production. And you can also have separate environments that are not chained together to do end-to-end releases, allowing you to do various scenarios. And the good thing about the clusters is that inside of your cluster, you can have multiple logical deployments by using namespaces. So now we had a namespace for .NET Framework Days, but I could have a pre-production, acceptance namespace and a production namespace inside the same cluster. And what you usually do is you have a production cluster for this one, and you have a pre-production cluster with dev, test, acceptance. And those are physically separated, so nothing from the test and acceptance can go on to production or connect to that. And you can have isolated environments where you still have, you go through pre-production in various stages before you hit real production on a real production cluster. We're out of time. We have a question.
When we use release feature, does it mean we need to restart our server each time when we change the stage? Because it's defined in startup class.
Yes, okay, so the question is, if I do the feature and I need to switch it on and off, do I need to redeploy? The way I showed you, you would have to do that because it's inside the JSON file. If you, or do I need to restart? It sort of depends on how good your line of code is evaluated. Is it evaluated once or more than once? So if we go here and how often is this evaluated? If it's dynamically evaluated, if it's on or off, then you don't have to restart. But it doesn't really matter if you need to restart, because if you do, you will just deploy again to your cluster, and the cluster will do a rolling upgrade. So we will just update all of the worker nodes, and you wouldn't even notice and have no downtime. So yes, it depends on how it's implemented, which framework you use.
Sorry, you use long-term update, but why not Canary update? Canary deployments. Canary deployment.
Okay, so the question is, if I hear correctly, can you do Canary deployments? Yeah, okay, I'll show you a picture. Let me show you that quickly. It's this one. So if you want to do Canary deployments, what you would do is you have your original version deployed, and you...
The new version, and I transferred some traffic to my new version. If my new version is working bad, I simply roll down my deployment and I use the previous version.
Okay, so in this case, you could revert to the previous version and discard this one, and or you can combine it with the features to switch them on and off. So you can have the new version here behind feature toggles, try it, and if this is not good, you fix it, deploy this one again, and you start using it again. But if you turn it on, and it's immediately for everyone, you wouldn't have a real Canary release, right? So you would try to start using it carefully with the feature on, And if it turns out that it looks fairly okay, you can do more traffic to that side. Because one of the things that we ran into is that it all looked fine in test and acceptance, but as soon as we hit the full production workload, obscure bugs like memory leaks started surfacing that we didn't see before. So starting carefully, ramping up the percentage left to right, so more to the right, then all of a sudden you might see over 50% when it gets real traffic, then all of a sudden it might CPU usage or whatever, and then you say it's not good, go back all the way to the left.
For this case, automation or based on the Prometheus. Prometheus, so the element mentioned edge that these are huge law for this procedure, and he relates this deployment back.
Okay, so what you're saying is if I use Prometheus, which is an alternative to App Insights, Application Insights, which is, you can choose whatever you want, but just have instrumentation and telemetry. If that picks up that it's going in an alert, then you can revert the changes. That's what I showed you with, that was over here. So let me see if we had the releases. Remember that I showed you this part here, that it has these gates. And then you can check with Azure Monitor alerts. I'm not sure if there's a Prometheus thing, but I believe you can hook up Prometheus to Azure Monitor, and this will actually do what you're saying. So then you can say, okay, I want to revert this release and do something, do some action. Okay, I have no opinion there. So if Canary releases is native to Kubernetes, we should talk after the session. Yeah, okay. That's it. Thank you very much. And enjoy the rest of the conference.